Hello, everyone. My name is Felipe. I'm part of the Open Science Labs community, which is an open initiative oriented towards innovation and collaboration with open science and open source software. Today, we would like to present Introduction to Git and GitHub. Our goal is to provide a light overview about Git and GitHub to help beginners have a basic idea about these topics before they kickstart their journey with version control and collaboration. So that being said, I hope you enjoyed this quick presentation. So we have many ways to save documents and to keep the different versions of them saved. But for specifically for software version control, you don't want to use something like Google Drive or this common approach that we are used to. So what is Git? Git is a version control system or version control software. You can use it to basically keep snapshots of your software, of whatever you are writing in your documents. So it helps in collaboration. It helps a lot, basically, because you can keep track of everything that everyone that may be working on a project. And it's easy to get back to older versions and solve conflicts between versions. So I may be working in my computer, and another colleague may be working in their computer. And once you send our modifications to the repository, which will be explained in the next slides, it's easier to solve and to actually see the difference between our modifications and to solve conflicts, possible conflicts. It's pretty straightforward to learn the basic commands, and it performs pretty well. So why should we use version control? As I mentioned before, we may be used to, let's say you are working on a project for school, maybe you're writing a report or something, and it's very common to create a version 1, version 2, final 1, final 2, and then you create the final of the final, and then at the end of the process, you have like 15 files about the same report. And I'm considering here that you are working alone by yourself. So imagine that with other people collaborating together. So it gets it can get pretty overwhelming. So you need to email different versions here and there. It's easy to get confused, get a lot of versions in parallel, and sometimes it can create issues of maybe you can miss some content in the final version or put something that shouldn't be there at the final version as well. So with version control, collaborators can work in parallel. So I can send my changes and some other person which is in the same project can check my changes, see if it makes sense. Maybe it's someone responsible for the code base. They can check if my modifications meets the requirements or the criteria of whatever I was working on. And it's pretty easy to check the difference between file or many files as well. So that's why we need to use version control. We need organization and we need to straightforward solution for collaboration between many persons. So, okay, Git is a system, okay? It's a software basically to versioning your software to control the many versions of code base software project. So, what is GitHub? Uh, GitHub basically is it's a Git service provider. So, not only it's not only a place to host Git repositories, which is the name for the folder, let's say, that keeps your code base. They also offer social networking functionalities, so you have like comments, discussions, conversations. You have your own profile where you can show your projects, ideas. You can have uh, snippets of code that you can share with your colleagues, your friends. Also, you can check other projects. So mm, almost always the open source projects are hosted in GitHub. You can give feedback. You can find some issue uh, in open source software, and you can actually open an issue, which I will comment in another slide. But you can actually give feedback. You can request some feature from a project, and you can propose changes as well. And also, you can contribute. Actually, you can clone the repository or download the repository from some project and make some modifications and actually push these modifications to the project so the contributors can evaluate if your contribution is fits their needs, the project needs. So that being said, Git is the software behind the scenes software that gives the version control functionality, and GitHub is a provider, so it's a cloud service. It's kind of like a social network for developers, let's say. So it helps a lot in terms of using Git, because otherwise Git you would need to set a server to host your repositories. So GitHub it's pretty straightforward. Is the most used Git provider out there. So yeah, that's the difference. So the installation is pretty straightforward as well. If you are using a Linux or macOS, generally most Linux distributions you will find it's already installed. And for macOS, you can use Homebrew. And for Windows, you can actually download the installer and just run the wizard. After installing it, you will be able to use the git command. So a few terms to know. Repo and remote repo here is swapped, so I'm sorry. So basically, the repository is the directory or the folder, the root folder that you are tracking. So it's kind of like that folder in Google Drive that you are referring to track your files. Local repository is the copy, let's say, that we have in our local environment, in your computer actually, and that we can work on. And the remote repository is basically the source of the truth, let's say. They are located it's the source, is the repository in GitHub or other Git providers that we clone the code from. So maybe you are working on a company or a project, open source project. The code base will be hosted in a remote repository. Okay, then we clone this remote repository to a local repository and work on it. So let's get our hands dirty, learn a little bit about some basic commands. So git commit, git push, and yeah, actually you don't need to execute. Okay. So what is git commit and git push? Before we get to the git commit and git push, first we need to learn how we start our actual Git repository. So after installing Git, you have a set of commands, subcommands that you can use with Git. One of them being init. Git init creates an empty repo. So let's say you're creating a web page, you're doing some HTML and some JavaScript. Okay, now I want to save this code, my progress, and I want to actually push it to some. I want to push it in the future to a Git provider. I want to host my repository and have other people working on that as well. So you can just use git init, and then this directory, Git will create all the files necessary, like a .git subdirectory, which will contain a lot of configuration and everything necessary for Git to work. So git init, just create a repository locally. So it's just git init. Then another common comment, let's say you just add your index.html and some CSS, and now you want to start tracking those files. You can use git add for doing that. So you can do git add and point to a specific file path if you want to add that specific file, or you can use the Unix dot notation, which will add everything. So every file that you have will be added to the modifications you are doing now, which we call you will start tracking the files, and they will be added to the staging area, which is the content that you want to add to your modifications. You have Git status, which shows some, okay, what files you have to, are you tracking, what are untracked files, which you are not at, you didn't add to Git, and which of them are in the staging area. So you can have an overview of what you're doing currently. And then you can check things before you commit. Git commit, it, as the subcommand says, you actually commit your changes. So let's say I use it git add. Now I can confirm the staging, those files that I was tracking. So git commit will create a unique ID, which is the commit hash or ID you can call. It's a unique ID for which identifies every commit. So it's basically saving a snapshot of whatever you're doing. Wow, I have modified 2 files. You create this commit, then you can undo, get back. You can have like a history. That's how the snapshots are created, and you have a history. So each point can basically represent a different commit. Let's say you have this commit, commit. So this difference here is what we would call branches, which I will mention in our next in future slides. So git push. All right, so I have committed my changes, but now they are just in my computer, right? It's only my computer. So how can I share those changes? I can actually use git push. So git push will literally push my changes, my version to the source of the truth, okay? The remote repository. So generally origin is a placeholder to referring to my remote repository, which is the code base, the main code base that we want to push our changes to. So this means that I want to git push to the remote repo, which is called origin in this case. And the master is basically the name of the branch. So nowadays this is used as main, okay? But so git push to the master branch in this repository, which is it's a placeholder for some remote repository. So this is where actually push your code, your version through the internet to the remote repository, which is hosted in GitHub or GitLab or any other Git provider. Okay, so every time you commit, you have this unique ID generated. So you have a snapshot. So if you do a lot of commits, if every time you do some change, you push, you you will have this registered as another commit, basically. Okay, so Git remote basically it's the source. Okay, so this is pointing to the repository in the GitHub or hosted in a GitLab or whatever Git provider. So when we are working locally and push to the code, we are pushing our code to these remote repositories, like we are uploading some document to the Google Drive, let's say. And you also have the pull, is when you want to pull the code from the remote repository. So let's say your friend have had some modifications to the code base, then you can pull from the remote repo and get those changes in your local repo. So yeah, the remote repo is started on a code hosting service like GitHub. You can also add many origins. Um, you're not stuck with one. You can have like a different remotes for the same pointing in your same local repository. So you can have many other remotes in our local repository. So yeah, it's pretty important. You should have the habit of committing your changes and pushing every time you do something. So you can rest in peace, literally, that you want, even if something happens with your computer locally, the modifications are already pushed to the cloud, to the remote repo. So there is no risks of losing your progress. Another very useful and common comment is git log, which basically lists a series of commits. It shows when you did the commit, who did it, at what the commit message, some if the commit has what files. We can check the files changed. We can check the stats of the commit, if how many lines of code were actually added or removed. So git log is pretty important, yeah, when you want to have an overview of the history of the repository, basically. Git stash is another useful command. Sometimes you are working on something or you have some idea that you're experimenting, but you need to do something else. You need to commit something, or maybe you need to check out to another branch, which we'll talk about branches in a minute. Then a pretty useful command is git stash. So git stash basically will get all the files you didn't commit yet, and you will be able to that you are not you will basically remove all those files to the stash. So it's a specific part where those files will be stored. Then you can like check out to another branch or do just a minor a minor change to the current branch and push it, commit and push it, and then later on you can get the files that you stashed and get back to work on that. So sometimes you need to like, it's just a save state, like, okay, save this for now because I don't want to commit it. Git stash, just do git stash. Uh, Fork is a way that Git hosting providers offer you to copy some repositories. So sometimes you don't want to copy it locally. You just want to copy to your, it's like copying a file from a Google Drive from someone to your drive. So you're not downloading the file. So Fork is just cloning the repository to your account. So basically is that. Let's say I have a repository A, and you want to copy it. So you fork the repository. Then that same repository A will be cloned to your GitHub account, let's say. So git clone is kind of it's you copy the repository, but you actually copy it to your local machine. So you do git clone and the address from the repository that you get from the GitHub, and then this will copy the remote repository to your local machine, and then you can start working on. Pull request is actually a pretty important concept in Git, in version control in general. So basically, okay, I mentioned that we can push our modifications to the remote repository, but they are not actually accepted. You know, we have generally speaking, we have a branch, a separate branch of this different version of the software of the project. And then we need to open a pull request pointing to those modifications that we have worked on. So when you open this pull request, we get in evidence everything that we worked on. GitHub shows the other members of the project the collaborators can check what you did on the code base. They can suggest changes. Then can like maybe they can suggest that you should maybe add a test or something that is not maybe is not looking so good, and you didn't notice something that is wrong in the code. Basically, you have a conversation there. It's like a final review about your changes, and this is the last part before the code is actually merged. So your modifications add to the main version. Okay, so the main branch. So also we have issues. So issues are basically kind of like a forum post, like a social media post, but they are related to a specific repository. So let's say you have a feature suggestion to a specific project. So you can open an issue for that. Let's say you have found a bug. You can open an issue for that as well. You can have an issue to plant features that people will be working on, collaborating on. You can tag friends and other members of the community about something. You can, hey, this issue is about this bug. I would like to maybe have two more people working with me on that. So basically, they are kind of like posts. And when you have a pull request open, you can actually link to issues, and those issues can be solved they can be closed after the pull request is merged. Because if the pull requests, which are is pointing to specific issues. If it was merged, it means that the issues was actually solved. Okay, so they are closed together. Oh, sorry about that. Sorry about that, guys. So branching. A branch is, as we saw in this figure here, in this image, you have the main version of the software, but you don't want to work on this, okay? This is the stable, let's say. It's the software that is actually working. It's the version that is working. And so when you start working on some feature, let's say, you create a branch. So the branch is like, it gets a snapshot from this state, and then we start working here. So when your job here, you're done, okay, I'm done with the modifications, then you open the pull request. So after the pull request is approved, then it's merged. The main version merges this version, this modified version, and becomes unified again. So basically, when you want to create this snapshot that I mentioned, a branch, you do git branch and the name of the branch. So you can, let's say, git branch version, git branch feature A. Okay, so you're adding something like, let's say, git branch homepage. You will create a branch called homepage, which will have a snapshot from the whatever branch you are like right now. So let's say you are in the main branch. So after creating the branch, you should go to this branch, change this branch. You can use git checkout. So git branch, create the branch, and git checkout, move the head of the git. So you go to this new branch. Also, you can delete the branch. Okay, if you just type git branch, you will see a list of branches. And if you want to delete the branch, you can use git branch -d for delete and the name of the branch. Okay. So as I mentioned, after your pull request is approved, then we can merge the modifications. So basically, you integrate those changes from another branch, like a home page. I can merge the home page branch to the main branch. So the target which receives these changes is always the one that you are current checkout. So if I want to merge home page to the main branch, I need to be checked in the main branch. So I do git merge home page. And then the home page branch will be merged to the current branch I'm in, that I'm checked in, which is the main branch, let's say, for example. So yeah, so the pull request is a step which we need to do a lot of back and forth, get a lot of feedback on the current state of work before the others collaborators can accept our changes. Another important thing is the git ignore file is .git ignore. Basically, you don't want to, sometimes you have files that you don't want to send to the remote repository, okay? So let's say node modules for people which are used to work with Node.js. They have the node modules folder or directory in the current directory. They don't want to keep it in the version control because then another collaborator, then they might be using another operational system that have actually different dependencies. So this should be installed locally. Okay, so we don't want to. We want to host only the software itself, the library. okay? Not like virtual environments or I don't know, cache files. Those are they should be added to Git ignore. So it's pretty easy to do. You just open .git ignore in your text editor and add like node modules, and then the folder won't be tracked by Git anymore. Okay. So yeah, guys, thank you for giving your time, your attention until here. I want to say thank you for Abhijay and Satarupa for doing the presentation for us. And it was my pleasure to have this quick talk with you guys. And also, I would like to give to share a last message. We will have a internship in Open Science Labs soon. So stay tuned. Please join our Discord community if you are interested in knowing more about the internship. Basically, you can contribute. You can have a mentor, and they will help you contribute to some libraries. So if you are just getting started, you want to get your hands dirty and learn a little bit more about the software development workflow and have other people more experienced helping you in during this process, please visit opensciencelabs.org/programs/internship, and also join the Discord community too if you have any questions, you want to know more. Okay. So thank you guys and see you in the Discord community. Okay. Bye bye.